Welcome to our first video of the year. In this video, we're going to talk about the definition of chemistry, as well as the different classifications of matter. You are going to need either a notebook or the fill-in-the-blank notes that I provided for you on Classroom. You're going to need something to write with. If you don't have all those, pause the video until you get them ready. But if you do have all of them, let's go. So we'll start off with a brief definition of chemistry, because that is the subject that we're supposedly studying in this year. Right, and chemistry is just the study of matter. We talk about the structure of matter. So one of the things we'll do later this year is we'll talk about how the different atoms will combine together, ionic versus covalent bonds, what types of shapes those molecules will take on. We'll talk about their properties based on the bonding and shape that they take. We'll talk about the different chemical and physical changes, right? So things like chemical reactions, patterns of reaction. And we'll talk about the energy changes involved in those changes. So if I were, for example, to burn a piece of paper, how much heat would I generate by doing so? Now, as far as what matter is simply put anything that has mass and either occupies volume or takes up space, right? So in order to be matter, it has to have both. Wind, for example, is not matter because wind does not have a mass and wind does not occupy a volume. Air is matter because air does have a mass if you were to weigh it, and air does take up some amount of space. All right, so that's what matter is. Now, what we're going to get into is we're going to talk about the different classifications. So the first one we'll start off with are pure substances. In a pure substance, all the particles in that pure substance are exactly the same, right? So in the diagram I have over on the right, that little left circle is water. Every particle in that water sample is a water molecule. There's nothing different in there. Pure substances consist of two different types of matter: elements, which are hydrogen and oxygen, and compounds, which are things like water. Now, one of the things that you can do is you can break compounds apart into their elements using what are called chemical changes. We'll get to that again in the next video. Right, so the chemical change that we're doing here is we're adding electricity to water, and that's causing the water to change into hydrogen gas and oxygen gas. All right, so elements. An element is just a substance that cannot be broken down any further into any simpler substances that still have those same properties. Now, a lot of the element names that we're going to come across in the periodic table, and especially their symbols, have origins in Latin or Greek. For example, the symbol for the element lead is Pb. It comes from the Latin word plumbum, which is where we get the phrase plumbing. In the upper right-hand corner of that diagram that you see is mercury. Mercury's symbol is Hg. It comes from the Latin phrase hyper argentum, which means quicksilver. Quick because it's a liquid, and silver because of its color. Each element has its own unique chemical and physical properties. One of the things we're going to cover later this year is we're going to go into the periodic table and figure out, based on where an element is located, what its properties are going to be, because we can actually predict these things, right? So I can say, for example, if I know that lithium is a soft silver metal, and when I put it in water, it forms hydrogen gas, it fizzes and bubbles, I know that if I go further down the table to like potassium, potassium is a much softer metal, it's still silver, and when I put it in water, it will explode. Right? This is all based on periodic trends, which is a unit we'll cover a little bit later. Okay, so these are elements. Now, elements, again, not the smallest particle you can get, but the simplest substance. The base particle of an element is an atom, right? An atom is the smallest particle which maintains the properties of that element. So a gold atom is the smallest piece of gold that you can have, which still behaves like gold. So I have a sample of gold over on the right, little particle diagram showing all the gold atoms. What you have down on the bottom is what's called a scanning electron microscope image of gold. So this is what gold actually looks like on an atomic level. Now, thing to keep in mind is that these atoms are really, really, really small. They average about what's called 1 angstrom, or 10 to the minus 10th meters. A good idea is for about an angstrom is take a piece of your hair, take the thickness of your hair, divide it into 1 billion pieces, and that will get you a good idea of how large an atom is. All right, so atoms are the basic element or the basic particles of elements. Our other pure substance is called a compound. Compounds are just different types of atoms that are chemically bonded to each other. Right? A bond is just a very strong attraction between atoms that comes about because you are either gaining or losing, which is ionic, or sharing, which is covalent, electrons. Now, the way that we represent a compound is we represent it using a chemical formula. The formula is based on how many of each atom there are in a substance. So the molecule I have on the right is the molecule TNT, trinitrotoluene. Technically 2,4,6 because of organic naming rules, but the chemical formula, if you go through, there are 7 black atoms, which are carbon, 5 white atoms, which are hydrogen, 3 blue atoms, which are nitrogen, and 6 silvery or 6 red atoms, which are oxygen. Right, so that gives us C7H5N3O6. Okay, so those are compounds. So the smallest part of a compound that can exist is a molecule. Again, most molecules are going to be atoms of different elements that are attached to each other and form a compound. There are some molecules out there that consist of only one element, so they kind of break the rules a little bit. These are what we call diatomic elements. This is a list that I'm going to have you memorize, and it becomes fair game for a pop quiz at any point during the year. Right? These 7 elements exist as molecules. The easy way to remember it is to remember to have no fear of ice cold beer. If you're 21 or older, please use diatomic elements responsibly. Right? These elements are hydrogen, which is have, nitrogen, no, oxygen, of, fluorine, fear, chlorine, cold, bromine, beer, and iodine, ice. Whenever you see these elements by themselves, it will always have a subscript of 2, right? So when I talk about oxygen gas, I'm not talking about O, I'm talking about the O2 molecule, the diatomic. Our next major classification of matter is called a mixture. So pure substance is only one type of particle present in a sample. A mixture then has to be when you have multiple types of particles or multiple pure substances in the same sample. There are 2 different types of mixtures that we're going to work with. The first is called a homogeneous mixture, otherwise known as a solution. In a homogeneous mixture, the different pure substances are evenly or uniformly distributed throughout. In our second type of mixture, called a heterogeneous mixture, the pure substances are not uniformly distributed. Right? Homogeneous, so homo means same, hetero means different. Right? And that's just talking about how they are distributed. Now, you can separate mixtures using physical separations to get their individual pure substances, right? So if I had salt water, I could use a physical separation to turn that salt water into solid table salt, sodium chloride, and water. Now, just to briefly give some examples. So for a homogeneous mixture, some examples. Air is a homogeneous mixture. It's mostly carbon dioxide, right? Air is about 78% carbon dioxide, 21% oxygen, and about 1% everything else in the air. Alloys, which are different mixtures of metals. So for example, the gold that I have down bottom, 18 karat and 14 karat gold are different alloys. Saline solution, so salt dissolved in water, is a homogeneous mixture. Kool-Aid, same thing, right? You take the Kool-Aid powder, you dissolve it, it all becomes evenly distributed throughout the entire sample. So for some heterogeneous mixtures, most foods are heterogeneous, right? So chicken noodle soup, perfect example. If we look at it, you see that the carrots aren't evenly distributed, the chicken isn't evenly distributed. There's like this clump of celery in there in the bottom center, right? So not at all evenly mixed. You have these little concentrations and clumps in there. Sand works the same way, so does fog. There are a lot of examples of each. These are just a couple of them. And the last little thing here I want to go over quickly is the classification scheme, right? This is how you break down matter. So we start off with our blanket description of matter. We talk about, does it have only one type of particle or multiple types of particles? One type of particle, which is constant composition, is a pure substance. Multiple types of particles, which is variable composition, is a mixture. Pure substances can be broken down into elements and compounds based on how many different types of atom you have, right? So if everything, for example, is a copper atom, that's an element. But if it's a copper atom and some chlorine atoms, that's compound copper chloride. Compounds can be broken into molecules, elements broken into atoms. Mixtures, based on whether or not they're uniformly distributed, will be either heterogeneous or homogeneous. All right, so that is our classification of matter. That is it for this video. In our next video, we're going to be talking about properties of matter, states of matter, changes of matter. All right, so I will see you guys then.